Now we are going to look at a little mathematical equation. It's a cubed equation, the simplest one, where cubed number is equal to a real number. So if we look at the problem here, I can try to move this so we can see the problem. The problem is x squared is equal to a squared, and for simplicity here of thought, we can see that a is a natural number, except a positive natural number, not 0. 0 is a trivial solution. Then x to the third is 0, and the only number satisfying that is 0. So if we look at this one, a is clearly a solution to the problem. But this is a third order equation, and as such should have two other solutions or roots. So for that to be true, they have to be real. Not real, but complex. And how come? And what are these solutions? We can, by inspection, we can see that A is a solution. We can solve this in several ways. I have shown a graphical solution and one with calculus or calculations. And for the graphical, we can just move this paper. So I made a circle here with the real axis here, and then the real vertical axis, or what we call the imaginary axis, on here. And the solution is A. And any solution, when we look at a complex number, they would be complex conjugate, of course, these numbers, they have to be on this A circle. It would be simplest to show this using the number 1. And the other thing here is that if we are going to do, if it's going to be a complex number, we know that the angle here has to be 120 degrees. We have a 30 here and 60 left, and so on, and conjugate. So it has to be either 120 degrees rotator or minus 120 degrees. And the length here has to be A. So this is pretty simple then, by inspection. X1 is A, yes, this one. This is X, but I just labeled them 1. The second solution is A, e to the power minus j 120, this one. And the third one is the positive one up here, this solution here. So because if you are squaring this number, of course here is x minus A is 0. We are going to use that later on. But if we are going to rotate or cube this number, the second x cubed would be the cube of this one, which would be A cubed. And then this one would be minus j 360. 120 times 3 is 360. And 360 is 0. And e to the 0, or any number to the power of 0, is 1. So that's A3. And similar with this one down here. And the rotation, this is the E here, it's just a pure complex number. It's just it's a complex number, and multiplying by itself is just rotating it. And multiply 3 times is rotating 3. So 120 first rotation, 240 for the second, and 360 for the other one. And then we minus 120, minus 240, and minus 360. And also by inspection, of course, we can decompose this when using sine and cosine and stuff like that, but we can also look at the triangle here, which is an equilateral triangle, which means there's 60 degrees, 60 degrees, 60 degrees, and the normal here is divides this one in a half, so the B here is a half. And we know that the tangent to 60 degrees, this angle here, is the square root of 3. Can be calculated. So the B here, so this height here is a square root of 3b, and b is a half, and here's a half. And then we can just write the equation minus a half, the b, plus j up here, square root of b, which is a half, And the conjugate number is the same real part, and then a negative on the imaginary part here, or the vertical real part. Yeah. So we look at it. Okay, this was not whispered, but you can see. But the figure here was whispered. Okay, so that was one solution to the problem, and of course we can do this using split math. Just have to get another paper. Yep. And it's the same here. We can say, okay, this is the original equation, and this is any real number except 0. So we just write a cubed, x cubed is a cubed, and then we have x cubed minus a cubed is 0. And then we know one solution, so we can factor out the x minus a. It's done over here. You can do it with division, straight division, get to the remainder 0, and then you get this second order equation. But you can also do this by inspection. There has to be an x squared here to get x to the third when we multiply in. There has to be an a squared here to get a to the third when we multiply this one parenthesis out. And the middle here, since we are going to end up here with an x and something in a, must be a. So we don't need to do this division here. So x equals to a, of course that's 1, and then we have to solve the solution. And you could use this formula that you have. But what we can do here is a little trick. We just add 0, so we add a to the square fourth and subtract it on the left-hand side. And then also we add on each side minus a2 plus a square half, and then we cancel out these two here. Okay, and then we are left with this one here. And of course, this is 4a squared divided by 4 minus, of course, plus a is not to the a over 4. And that's minus 3a squared fourth. And here is this one, and of course this is not a square here. That was not a square, that should be removed. And then we take the square root on both sides, so then we have a plus minus here, and a squared over 4, that's a half. And then we are left a minus square root of 3, and then we filter out a j or an I on the imaginary indicator, which is the square root minus 1, which means that x equals plus minus a half, and minus a half plus minus j, let's just move that in front, a half over and square root of 3, which is what we got by just looking at the problem. This is a little harder. It's not that much math, but this is valid then for all a's in all real a's, and it's also valid for 0, because if a is 0, we can look here that okay, one solution is a is 0, and these two other solutions there is 0 and 0, so they just cancel out. So there are 3 0 solution, which is basically just one solution of 0. But just to have numbers, I would say okay, we exclude 0 because that's a trivial solution. Okay, so that was a quick one with some cubed equation, the simplest cubed equation we have, which you can solve just by using a figure and look at this. What we have to know is how to write complex number on its polar form using e, and the magnitude in front of it, and we know the solution. Then the magnitude in front of it had to be a, or the number that's being cubed that you are looking for. And then is this rotation. We have to rotate so we can get back to 360, which is 0 degrees, and e to the 0 is 1. So then we can say, okay, the solution is a to the third for the the complex conjugate pair, and also for the real part. And then we have 3 roots, which a cubed equation should have or has. So that was a quick one.